Hi, my name's Kevin Lacker. I work on the Facebook open source team. And today I'm here to talk to you about JavaScript fatigue. Specifically, I would like to convince you that JavaScript fatigue is a good thing. It's healthy for the ecosystem. It's a good feeling for you to feel. And your projects will be more successful if you understand the nature of JavaScript fatigue, you understand the power behind it, and you learn how to use that power to your advantage. So, what is JavaScript fatigue? Well, what is fatigue? Fatigue is how exhausted you feel when you're doing something hard for a really long time. You're running a marathon. You think you're a good runner. You got all your equipment. And you start running, and then slowly your feet start to hurt. Your legs start to hurt. Every step is exhausting, and it feels difficult. You're running out of breath, and you think, after a long, long time, you think you're almost done. But then you look up, and the sign says 0.2 miles. You're only 1% finished, and it just hits you right in the core. Ugh. You start wishing, if only this was a sprint and not a marathon. And in JavaScript land, as more and more stuff launches, a lot of people are feeling fatigued by the progress in JavaScript. So more specifically, check this out. So this right here, I went to Hacker News for the past 2 months, and I grabbed every article that was the launch of a new tool in the React ecosystem, with at least 100 upvotes. So this is right at the top. And this is the face of JavaScript fatigue. You might think that anything that hundreds of people like in your community, a responsible React developer should be aware of these tools and have an opinion on them. But this is one new thing every 3 or 4 days. So it's just impossible to learn all this stuff. And for new people who are just getting into JavaScript especially, people will come to me and say, hey, you and all JavaScript developers, the JavaScript community, you're doing the wrong thing. This is exhausting. Don't do it this way. You should do things the opposite way. So what is the opposite philosophy to JavaScript fatigue? Well, the opposite philosophy, I think, is the right thing. Why don't you just figure out the right thing and build it? Then we wouldn't have to be fatigued when this new stuff launches all the time. It sounds good, right? The right thing? It feels good? Don't you want the right thing? I mean, it's called the right thing. This is so linguistically simple, so linguistically obvious, I think we take it for granted sometimes that this is the right philosophy, that we should figure out the right thing and build it. But it's clear that the JavaScript community is not following this philosophy. We're not building the right thing. We're building all sorts of things all the time. And we feel guilty, especially when people who are new to it ask something like, hey, can you just point me to the one reference for how to do JavaScript? Can you just, that exists for Rails, that exists for, making an iOS app with Objective-C. What are you doing wrong here? But I don't think we should feel guilty. I think the right thing is the wrong thing. I think this fatigue, this thing that's happening, is actually a sign of strength. Throughout the history of computer science, the most powerful developer tools, the most powerful developer platforms, and the most successful ones have not been the ones where someone sat down, thought hard, and built the right thing. But to prove this, we're going to have to look at this ancient history. Let's go all the way back to the dawn of time. That's right, the dawn of time is 1970. Some people don't believe this. I mean, not many. Most people, when I say the dawn of time is 1970, they say, oh, wow, time went back that far? Okay, man, if you say so. But some people object. They've heard rumors that time before 1970 existed, but I'm pretty sure that's not the case. And I can prove it. Look, just drop in a node. What is time 0? Oh, there you go. The dawn of time is 1970. And it's a Thursday. Go figure. So the dawn of time is in 1970 because when the Unix timestamp system was set up, it was the 1970s, and this saved a little space. And then there was a whole set of things built on top of it, culminating in JavaScript. And we kind of take it for granted now that all these systems are built on top of Unix and these Unix assumptions. But it didn't have to be this way. There was actually a massive competition going on between operating systems and programming languages in the era before consumer computing, before Windows. Unix was really closely tied to C, so it was really common in Unix to write software in C. But in particular, there's this competing programming language called Lisp. Lisp, as you can see, if you're not familiar with it, it's mostly parentheses, which is why it's often considered to be a very beautiful programming language. Because the parentheses, if you think about it, are the most beautiful character. They're symmetric, pleasantly rounded. Study hard here. And nowadays, we take it for granted that every new programming language, it just has to run on a MacBook Pro. But back then, the hardware was more of an open question, and in particular, the best machine for running Lisp was something built for it from the ground up, a Lisp machine. Just like in Unix, it's built so that, in Unix, a C program is very native to it, and a Lisp machine was built from the hardware so that a Lisp program would be native. Things like car and cdr really mapped onto hardware notions. So there were multiple companies in the 80s that sold these, and there was a real competition. So when you compare Lisp to C, well, even nowadays, decades later, people will talk about the innovations in Lisp, like macros, and the fact that the programming language itself is basically the same as the abstract syntax tree. And these things aren't really matched by modern programming languages. But Lisp still lost out, especially to C and Unix. And one Lisp fan, brilliant guy, Richard Gabriel, had a theory that really figured out why, I think, that he called worse is better. So the meaning of this name is just to contrast it with the right thing. Worse is better in the sense that sometimes doing what seems to be the right thing leads to the ultimate failure of your project. So Richard Gabriel has this whole sequence of essays. You can find them if you're familiar with the internet, where he breaks down what he sees as the distinction between these two philosophies. So the right thing is built on, there's all these principles that good software should have, and you should fit all of them. Your software should be correct, so you should definitely think a lot about what correct is. You find some correct way to do things, you create a design, you create an intelligent one that's consistent and complete, and don't forget you should also make it simple. Doesn't this feel like the right thing? And you can kind of feel like when Richard Gabriel was writing this up, he wanted to build the right thing. Software should have all these qualities, right? But there's a different way to build software. It's similar, except all of these things have a different importance. In particular, worse is better is almost the ultimate in laziness. You really, really, really want to build something simple. Being correct or consistent, well, that's nice. Completeness, almost don't worry about it. So if you think about this, what sort of system do you want to use? Do you want to use something where the author kind of punted on correctness? Oh, it sounds bad, but why did C win out? It seems like if you compare between the right thing and worse is better, you'll just prefer the right thing. But there are many advantages of this worse is better strategy, this simplicity above all else. In particular, simple things are easier to integrate with an existing system. In the Lisp versus C wars, the existing systems that mattered were computer hardware. C is basically a slightly fancier version of assembly, so it was far easier to write a C compiler for new hardware. Even if it would have been better to have a Lisp compiler, you're basically always restricted by engineering effort, so a lot more C compilers were available. I think there's a parallel here to the modern world of JavaScript, and in particular to the rise of React. So this is one of the earliest posts from the React blog, back when the general reaction of the world was still, this React thing is no good. And the two most important things about React here are things that React does not do. React is not an MVC framework that gives you a model, a view, and a controller. And it doesn't use templates, which many people love. So let's look at MVC. Why would you, when you build an MVC framework, there's a tool for every part of your application. You know how to build the model. You know how to build the view and the controller. There's something for everything. There's a tool for each part. Isn't that the right thing? Why would you not want to provide a tool for something? Well, the React method of focusing on the view is definitely simpler. So this adheres to the worse is better strategy. And in fact, it is also helping the adoption of React to make it simpler here, because it makes it easier to integrate React. Now, React doesn't get integrated directly with hardware, like a programming language might. It gets integrated with existing complicated applications. So, you have some application, and it looks like this because you built it with some other model view controller framework. You're thinking, hey, I don't know about this React thing. I'm not totally sold. I'm not sure if I'm ready to go all the way on the React lifestyle. I'm just React curious. I'd like to dabble in something new. If React was a whole MVC framework, you'd have to rip out everything here and replace it with something else. But since React just touches the view, you can just go doink. So if you think of this doink architecture, where you just take the existing architecture that was intelligent, and then you just kind of, you just jam some React in the crack to fix things up. You don't mess with the build pipeline. You don't mess with the server backend. You don't mess with any of that. You just have one little part of your page rendered in React, and then you see if it feels good. So this is actually how I got into React. I was working on a pretty complicated Backbone and jQuery application, the front end of parse.com. And honestly, I thought it was great. There was one guy on the team, Andrew M., who said, hey, we should check out this React thing. And like the clueless manager with very little understanding of the technology, I thought, hey, the status quo is so nice. Everyone already knows it. I'm really opposed to this React plan. And what sold me was he's like, hey, no one else is going to have to learn it. If you hate it afterwards, just keep it confined to this one tiny place. And I won't have to mess with any of the other parts of the application. I was like, ooh, that sounds non-disruptive. That's promising. And then once we had a little bit of it using React, we saw, hey, this actually works much more nicely. And it started to convince people. So the simplicity over all else really made it work. So that's the magic of the simplicity of, well, it's only a view. How about the other point, the fact that React doesn't use templates? From an aesthetic point of view, a lot of people hated on this original decision, saying, hey, it's not the correct design. So in fact, here is what I believe to be the very first Hacker News post about React. And the top comment is just saying, ew. So one lesson here is don't let it get you down when you post your cool new thing on Hacker News and you get one comment, it's just someone saying, ew. It could be the next React. I mean, in 28 points? Come on, that wouldn't have even made that list of the top 15 things in the past couple months. But the thing is, I get the ew. Sticking XML inside your programming language is weird. It's a little strange. Certainly wasn't the conventional thing at the time. And there was some, but not really a grand philosophy behind it, besides, well, try it and see. Combining your templating language with your code was mostly considered to be a hacky thing to do that wouldn't scale. But one thing that was amazing is that it made it a lot easier to adopt. Since everything is JavaScript, it's totally optional to use a templating language at all. So if we go back and look at this doink architecture, this works fantastically with JSX, because JSX is optional. You can just use React.createElement instead, and then you don't need to muck around with your build system. It's true there were downsides, especially at launch. Editor support was pretty absent. The toolchain support wasn't so great. But the upside of you can stick React into your existing code base without even adding any extra files, that's a pretty strong advantage too. So let's look at what happens here, what happens with this architecture, and why worse really is better. Because I'm not saying, hey, architect your software badly. What I'm saying is there's phases. The first stage is where the simplicity of a tool leads to its popularity. This isn't necessarily a recipe for something amazing. A lot of times things can get popular, Over time, you realize it's just a fad, it's not fundamentally amazing, and it goes away. What really makes worse better is the second phase after this, where simplicity leads to popularity, which then leads to more contributors. To win at worse is better, you have to be in an open ecosystem so that you can turn your popularity into helpful contributors, and then that leads to a better product in the long run, that you get more people working on this. And what all these people do is they go and fix up all the ways in which the original product was worse. It doesn't have to be people working on the core product. It can also be people working on integrations into other systems or helpful tools that work well in the ecosystem. This is what happened in the Lisp versus C battle. Originally, there was a big question around compilers. In theory, you can have a much more intelligent compiler that uses more intelligent tricks if you have a more intelligent programming language. And Lisp is really intelligent. So there was some theory behind Lisp should be faster here because it should have better compilers. But a big problem is you need people to work on it. And the more popular your system is, the more people will want to work on it. And now, decades later, there are many amazing innovations that come in compilers. And there are many teams that build amazing C compilers. And you can trust that basically any compiler innovation will get into C probably before anything else. So this model is also how React got popular. There were so many things missing at launch. So when Facebook launched React, a good compiler, well, there wasn't really a standard way to do language extensions. We had this tool, JS Transform. It was definitely, well, it was nowhere near what the Babel ecosystem is today. In state management, one of the big issues with only launching the V in MVC is that, well, what are you going to do to store your data? You need a model somewhere. And then subsequently, there were many tools built both by Facebook and by other people in the community. Flux and systems like Redux, MobX, Relay. And now it means there's many choices here that each have cool things going on for different applications. And it's just a much better state than if React had tried to build the correct solution from the first place. In routing, React Router being optional has actually turned into being a great strength. I mean, hey, maybe we'd have committed to the API in React Router v1, and then later realized we wanted v4. Maybe we would have adapted something that didn't work quite so well for React Native. In this case, the minimalism behind React made it easier to apply the same model to mobile development. In getting started tools, it probably would have been the right thing to provide Create React App when React was initially launched. But I think it's even better now than it would have been if we had included Create React App in the first place. So let me dig a bit deeper into Create React App. In fact, at first, this talk was only going to be about Create React App. But I realized the principles behind it were more general, so I wanted to expand the scope out. So this is the bottom of the README for Create React App when it launched. There's so many other people and other projects that had been doing something very similar, and Create React App had the luxury of looking at everything intelligent that happened in the ecosystem and taking time to craft what seemed to be a great set of choices from each of these tools. It's like, if you see further than others, it's because you stand on the shoulders of JavaScript fatigue. This shows how we can build something better when there's a community and we don't try to get everything perfect up front. We get to take more time. But the flip side is, when you're in the community and you watch these things come out, this is fatigue. Maybe you watched as Enclave, NWB, Motion, the other one of these great tools for creating a React project. You watched as they came out. You learned them, and you're thinking, oh, well, this is a little better, but now I have to learn this. I have to upgrade my mind, and I'm feeling the fatigue. And this is where the fatigue comes from. What JavaScript fatigue is contributors. Not necessarily contributors to your project, not necessarily contributors to React, but contributors to the whole ecosystem. The more people contribute by building a library, the more slightly different ways you have of looking at the problem. That's an amazing situation to be in terms of the quality, but it can be exhausting. The point is, this is the winning strategy. It worked for C against Lisp, it worked for the success of React, and it'll work for you in your own open source projects. Launch something simple, make it popular, and then later fill in the holes. The result of this is high quality, modular software that we love. The cost is this feeling of fatigue when there are new things launching all the time. So, JavaScript fatigue is the inevitable cost of our ecosystem success. It's directly tied to success. I hope we can see that the feeling of fatigue is at least justified. But there's really a question of how to deal with it. We still need a solution. JavaScript fatigue is this core phenomenon driving the success of our ecosystem. But if you feel exhausted by it, if you feel like it's a huge wave coming at you, then how does that help? How do you deal? What should you do when you feel this feeling of exhaustion? If you're exhausted because there are just so many libraries to learn. So the best solution, it might be counterintuitive, but just for you individually being happy, the best solution to JavaScript fatigue is more JavaScript. If you are exhausted by the huge number of libraries coming out, one after another, slightly changing things, making little improvements, and you find it tiresome, you should write your own library. Don't get knocked over by that wave. Surf that wave. The great thing about a rapidly moving ecosystem with new cutting-edge tools launching every few days is that there are so many opportunities for you to write your own tool and to share it and have it be cutting edge as well. Will your life be simpler? No, your life won't be simpler. But it could be awesomer. And then you will still feel that feeling of fatigue. But next to it, there'll be another feeling, a feeling of pride and excitement as you launch something that a few other people can use, or dozens of people, or hundreds of thousands. And when that happens, you'll feel like you completed the marathon. And then, when you feel like you've completed the marathon, before too long, you won't even remember that feeling of fatigue. All you'll remember is the joy. Thank you.